myself Dr. T. Sudarshan Ramaperumal. Today we are going to discuss about the routing and their supporting protocols. Routing and protocol. Routing is a network layer responsible for routing the packets from its source to destination. The root network layer is responsible for finding the best one among these possible routes. The network layer needs to have some specific strategies for defining the best route. Routing is the concept of applying strategy and running routing protocol to create the decision making tables for each route. Unicast routing. Routing is the process of selecting the best path in the network. In unicast routing, a packet is routed hop by hop from its source to destination by the help of forwarding tables. Routing is a packet from its source to destination means routing the packet from source router to the destination router. The source host needs to forward the table because it delivers its packet to the default router in its local network. Is a symbol graph for the unicast routing. A node of a graph labeled A through G may be a host, switches, routers or network. The edge of the graph corresponds to the network links. Each edge has been associated host. And there are three main classes of routing protocols: distance vector routing algorithm, link state routing algorithm, and path vector routing algorithm. In distance vector routing algorithm, we go for the routing information protocol. Link state routing algorithm, we go for the open shortest path routing call, and path vector routing algorithm, we go for the border gateway protocol. First one is the distance vector routing protocol and RIP. Distance vector routing is distributed algorithm to run all the nodes. Each node knows the distance to each other, each of its directly connected neighbors. Nodes construct a vector and distribute its neighbor. Nodes compute the routing table of minimum distance to every other node via nest hop using the information obtained from its neighbor. In the given network, host of each link is one hop. Each network sets distance 1 onto its immediate neighbor and cost itself 0. Distance of the non-neighboring marked as unreachable and infinity. Node A and node B, node C, D, E and F are reachable, whereas D and G are the unreachable. This is a initial table for A, node C and the node F. Here A to A cost is 0, A to B cost is 1 and A to C cost is 1, A to D there is no direct link, so the value is infinite. A to E cost is 1, A to F cost is 1 and there is no direct link available for A to G, so the cost is infinity. Like that all the tables will be filled. Since 2 is less than the infinity, entry of the destination T is from A's table change to infinity to 2 with the help of the nest hop table of C. So the final routing table of the node A will be changing. The infinity value will be converted into the normal number values, and this is a final routing table for the given graph. Routing information protocol. RIP is an intra-domain routing protocol based on the distance vector routing algorithm. Router advises the cost of reaching network. Cost of reaching each link is one hop. For example, router C advertised to A that it can be reached network 2, 3 at cost 0. Each router updates cost and nest hop of each network number. Identify it's defined by 16. That is, any route cannot have more than 15 hops. Their RIP can be implemented. Advertisement was sent every 30 seconds. This is packet format for the RIP. Command, it indicates the packet type. Version, it indicates the RIP version number. Address, family identifier when the value of 2. IP address, it indicates the destination IP address, and metric, it indicates the hop count of the router its destination. Count to infinity problem. Suppose link from node to A to E goes down. Node A advertises the distance of infinity to E to its neighbor. Node B receives a periodic update from C before A's update. Node B updates by C. Node A advertises to A, and node A runs updates C with the distance of 4 hops, and so on.